Another example of the Pythagorean theorem. Recall our formula is the sum of the squares of the legs of a triangle should equal the square of the hypotenuse if you have a right triangle. So you would say first leg squared plus second leg squared should equal the hypotenuse squared. In this example, we're given a right triangle and instead of having both legs, maybe I know the hypotenuse in a leg and I want to find the other leg. So let's say that the hypotenuse is 15 and this leg down here, let's call that 11. And we want to find this missing side over here, this missing leg, which we'll call y. Applying the Pythagorean theorem, I'm going to look at both of the legs and I simply go y squared, that's one of the legs, plus 11 squared, the other leg, should equal 15 squared. As I square these values, I get y squared plus 121 equals 225. To solve for y, I'll have to move this 121 over, and so I have y squared equals 225 minus 121. That tells me that y squared would equal, what is that, 104? And then I want to square root both sides because I don't want y squared, I just want y. So as I introduce the radical, this goes to y equals the square root of 104. An exact answer would be radical 104, but oftentimes we want a decimal approximation. So I go to my calculator and I'm simply going to type in here the square root of 104. And this gives me 10.198. If I round that to the nearest tenth, that'd be 10.2. So this is approximately 10.2. Go up to my picture. Just checking the reasonableness of my answer. I would expect that this leg would be smaller than the hypotenuse, and it is, so it seems like a reasonable, viable solution. And there's our second example on how to use the Pythagorean theorem to solve right triangle problems.